In this video, I'm going to go over section 8.1 and work some examples for you that you'll be doing in your MyMathLab assignment. So this chapter is going to be about sequences and series. So first I'm going to define what a sequence is. So sequence is simply an ordered list of numbers. Usually they're related somehow. Each term in the sequence is called a sub something. So 2 is the first term in the sequence, so it's a sub 1. 3 is the second term in the sequence, so it's a sub 2. 4 is going to be a sub 3, because it's the third term in the sequence. 5 is the fourth term in the sequence, and 6 is the fifth term in the sequence. 7 is the sixth term in the sequence, so it would be a sub 6. So in this case, each term follows this pattern that it is one more than the one before it. So if I want any term in there, I take the number n and add 1 to it. So for example, for term 4, I plug in 4 for n to get a sub 4. I plug in 4 for n and add 1 to it to get 5. So if I wanted to know the 100th term in that sequence up above, I would take 100 and add 1 to it. So the 100th term in the sequence is going to be 101. So here, if I'm going to find the first 4 terms of this particular sequence, this tells me how to get each term in there. So if I want a sub 1, n is 1. So in this formula, wherever I see n, I'm going to plug in 1. Negative 1 to the first power is negative 1 times 1 is negative 1. To get the second term, I'm going to take negative 1 to the second power, and then I'm going to square 2. So 2 squared is 4, negative 1 squared is positive 1, so we just get 4 here. For the third term in the sequence, we'll take negative 1 and cube it, and then we'll square 3. Negative 1 cubed is negative 1, and 3 squared is 9, so we get a negative 9. And for a sub 4, we have negative 1 to the fourth power, and then 4 squared. Negative 1 to the fourth power is positive 1, and then 4 squared is 16, so we get 16. To get the 23rd term, everywhere we see n in that formula, we plug in 23. And plugging that into the calculator gives us 529. So we can see the pattern of the answers we were getting here for the sequence. If we were to write out the sequence, our first term would be negative 1, our next term would be 4, our next term would be negative 9, our next term would be 16, and so on. So we could figure out what the next term is by looking at this term, but we don't have to. We have this formula here, how to find all the terms. So I don't have to find the first 22 terms in order to figure out the 23rd term. I can just use this formula. Recursive, however, you don't get a formula for each term. You get a formula for how each term depends on the term before it. So in this case right here, it's telling you that the very first term in the sequence is 1. To get any other term, you have to take the term before it. That's what this a sub n minus 1 means, the term before that term. So for example, if I'm looking for term 3, I would take whatever term 2 is, add 2 times 3, and subtract 1. So this is the formula for finding each term, but I need to know the term before it in order to get it. So if I'm trying to find the fifth term, I have to know what the first four terms are first, because I need to know what the fourth term is to use that formula. So in this case, a sub 1 is 1. A sub 2, we're going to take the term before it, which is a sub 1, and get 1, plus 2. We're finding a sub 2, so this time n is 2 minus 1. So that gives us 4. So now a sub n minus 1 is this. So we plug in 4, because that is the term before a sub 3. N is 3 for this problem. So I have 4 minus 1, which is 3, plus 6 gives me 9. A sub 4, we take the term before it, which we just figured out is 9, plus 2 times n, which is that number, minus 1. 9 minus 1 is 8, plus 8 is 16. And a sub 5, finally, we take that, the term before it, 16, plus 2 times this n, minus 1. 16 minus 1 is 15, plus 10 gives me 25. So the fifth term is 25. Here's another example of a recursive sequence. This one tells us what the first term is, and then tells us how to get each one after it by using a sub n plus 1. So this means the term before. So notice that's different than how they showed it in this one. They gave us a sub n, how to find each a sub n, and they said the term before was n minus 1. In this case, they give us how to find a sub n plus 1, and the term before is a sub n. So we are going to do the same thing we did before. A sub 1 is 5. They gave us that. A sub 2 is the same thing as a sub 1 plus 1. So there's our n plus 1. So we can see n is equal to 1 when we're looking for a sub 2. So we take 2 times a sub 1. A sub 1 was 5, minus 3, so that's 7. A sub 3 is equal to a sub 2 plus 1. So a sub n is, or n is 2 in this case when we're trying to find the third term. So 2 times the second term, which is 7, minus 3 is 14. A sub 4 is a sub 3 plus 1. And so a sub 3 was 14, so we have 2 times 14 minus 3. This is 28 minus 3 is 25. A sub 5 is a sub 4 plus 1. A sub 4 is 25 minus 3. So that's 50 minus 3 is 47. So those are our first 5 terms of the sequence: 5, 7, 14, 25, and 47. A series is taking those terms in your sequence and adding them together. So if I'm looking for S sub n, I'm looking for the sum of the first n terms, and we can call that the nth partial sum. So for example, if this is my sequence, 2, 3, 4, 5, 6, 7, there are 6 terms in that sequence. So if I want to find the sum of those 6 terms, that's S sub 6, I would add those terms together to get 27. If I was trying to find S sub 2 of that, so that series of just the first 2, I would add 2 plus 3 and get 5. So here's my sequence up at the top here. This is A sub 1, A sub 2, A sub 3, A sub 4, A sub 5, A sub 6, and A sub 7. So if I want to find S sub 1, that's just adding the first term. The first term is negative 2. I don't have to add anything else to it. If I'm trying to find S sub 4, I'm adding the first 4 terms. So it's A sub 1 plus A sub 2 plus A sub 3 plus A sub 4. That's negative 2 plus 4 plus negative 6 plus 8. Negative 6 and negative 2 added together give me negative 8. Adding 8 to that gives me 0, so this is going to be 4. S sub 5 means adding A sub 1 plus A sub 2 plus A sub 3 plus A sub 4 plus A sub 5. Well, we just figured out that this is 4, so we don't have to add that again. It's really the same as adding S sub 4 and then adding the next term. So that was 4, and A sub 5 is negative 10. So I get negative 6 from the sum of the first 5 terms. This is summation notation, so sometimes you can write a series using this notation. So what it means is, this is the formula for finding each term in the sequence. And then the summation means add all those terms up, just like when we do with the series. So my first term here is going to be plugging in 1 for k. So A sub 1 is 1 plus 1, or 2. My second term is, now I'm going to move on to 2. K started at 1, it's going to go all the way to 6. So k is 2 for my second term. K is 3 for my third term. K is 4 for my fourth term. K is 5 for my fifth term. And K is 6 for my last term. I know to stop at 6 because that's this top number. I know to start with 1, and I'm plugging each of those numbers from 1 to 6, whole numbers only, in for K, and then figuring out what the each term is. So the sum is going to be equal to 2 plus 3 plus 4 plus 5, oops, that's supposed to be 7, plus 6 plus 7. So that's 5 plus 9 is 14, plus 6 is 20, plus 7 is 27. So this is the same as the original series that we started with when I introduced what a series was. Here, it's that same sequence, but they didn't give it to us as a list of numbers. They gave it to us in summation notation, and we had to figure out what those numbers were and then add them together. Now, you can also do this with your calculator. So I'm going to set this up what it is, and then I'm going to show you how to figure out the summation with your calculator. So we're going from 1 to 5 for K. So my first term is going to be 1 cubed. My second term, I'm going to go to 2, and that's going to be 2 cubed. Third term is 3 cubed. fourth term is 4 cubed, fifth term is 5 cubed. Now this can be really tedious if this gets really long, if we have a lot of numbers in here, because I have to cube all of these numbers and then add them together in my calculator. The other thing that we can do is in your calculator, you can hit math and then go down to the 0. That's summation. So notice this A is blinking right here. That means alpha. And what that means is these letters are going to come up. So we want K. So I'm going to find where the green letter K is, and that's right above this parentheses here. So if I click that parentheses, it's going to put a K in for me. Then we said K equals 1 to 5. And here we have to plug in the formula. So we want K again. So we have to hit this alpha and then that parentheses again. And then we're cubing K each time. And that gives us 225 for that sum. So if I were to go through and with my calculator add 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed, I'd also get 225. So using that summation notation is a quick way to do that. This one, when I'm plugging in, notice we're starting at 0. So this is -1 to the 0 power times 5 to the 0 power plus -1 to the 1 power times 5 to the 1 power plus -1 squared times 5 squared plus -1 cubed times 5 cubed plus -1 to the 4th times 5 to the 4th. I know to stop at 4 because that's this top number. So I went from 0 to 4. And again, I can take my calculator, do math 0. We're going to do K, so that parentheses again. This time it equals 0 to 4. This time I have -1 to the K power times 5 to the K power and that gives me 521 for that sum. This last one starts at 8, so I have 2 plus 1 over 8 plus 2 plus 1 over 9 plus 2 plus 1 over 10 plus 2 plus 1 over 11. Okay, and then my calculator, math 0. So this time I have I. It actually doesn't matter which letter you pick. If you want to keep going with K, that's fine. If you get confused because you see an I here, go ahead and put I in. So I's here above the x squared. So I equals, and then it's 8 to 11. And then we're going to put in the 2 plus, and then I have a fraction. So we're going to do alpha y equals and enter to make that fraction. 1. I want I again, so I need to hit alpha and then that x squared again to get I. And that gives me this really ugly fraction, which is 3.3371 over 3.960. So to recap what you need to know for doing your homework assignment, know what a sequence is and how to find each term that they ask for when they list the sequence, know how to find terms of a sequence when they give you a formula, know how to find terms of a sequence when they give you a recursive formula, when it depends on the term before it, and then know how to find a series when you're given a list of numbers for your sequence, and also when you're given the series as summation notation. Your homework will be your MATLAB 8.1.